Hello everyone, my name is Muskan Siddiqui. My roll number is 205079. Today I am going to present on the topic Theory of Equilibrium. Equilibrium is a state of a body where neither the internal energy nor the motion of the body changes with respect to time. Let us try to understand what is equilibrium. A body is said to be in translatory equilibrium if the net force acting on the body is zero. If the force are conservative, then F is equals to minus du by dr. For equilibrium, F is equals to 0. So, minus du by dr is equals to 0. Or we can say du by dr is equals to 0. At equilibrium position, slope of our graph is 0 or the potential energy is optimum, maximum or minimum or constant. There is condition of equilibrium. So conditions, first condition is condition of stability of body with 1 degree of freedom when the work done is W is equals to F theta. So for the stable equilibrium, we have F dash theta naught is equals to 0 and F double dash theta naught is less than 0, which implies that stability of equilibrium for W is maximum at theta is equals to theta naught. Similarly, for the unstable equilibrium, we have F dash theta naught is equals to 0 and F double dash theta naught is greater than 0, which means that the stability of equilibrium for W is minimum at theta is equals to theta naught. So the second condition is general condition for stability of a body resting on another one. If the upper body has a plane face in contact with the lower body, then R is equals to infinite. So we have stable equilibrium for H is greater than R. H is less than R and unstable equilibrium for H is greater than R. Second is if the lower body is plane surface, then R is equals to infinite. So we have a stable equilibrium for H is less than R and unstable equilibrium for H is greater than R. If the lower surface is concave, then R is negative and we have a stable equilibrium for 1 by H is greater than 1 by R minus 1 by R. For unstable equilibrium, we have 1 by R is less than 1 by R minus 1 by capital R. So here is the types of equilibrium. There is 3 types. First one is a stable, second is unstable and third is neutral equilibrium. Stable equilibrium is that when a particle is slightly displaced from equilibrium and it tends to come back towards equilibrium, then it is said to be in stable equilibrium. Second is unstable equilibrium. When a particle is displaced from equilibrium and it tends to move away from equilibrium position, then it is said to be in unstable equilibrium. Third is neutral equilibrium. When a particle is displaced from equilibrium and no force acts on it, then the equilibrium is said to be neutral equilibrium. The situation where F is equals to 0 and du by dr is equals to 0 can be obtained under 3 conditions. We can see in first figure that a ball kept in a bottom of a ball, a marble kept in a bottom of a ball, which is stable equilibrium. And second is unstable equilibrium, in which we can see marble placed on the top, which is unstable equilibrium. And third is neutral equilibrium, in which a marble lying on the plane surface. Application of theory of equilibrium on a string. equilibrium of a string if the weight per unit length of the chain or string is constant. The catenary is called uniform or common catenary. Equation of common catenary. We can see this figure and let's check. Let ACB be a uniform, heavy, flexible card attached to 2 points A and B at the same level. C being the lowest of the chord. Draw co-vertical, OX horizontal, and take OX as x-axis and OC as y-axis. Let W be the weight per unit length of the chain. System of forces and its type. A force system is a collection of a force acting on a specified location. Does the force of a system shown on any free body diagram make a force system? There is types of force system. First one is coplanar and non-planar force system, non-coplanar force system. The force system in which all forces are acting on a same plane is known as coplanar, whereas in different plane are known as non-coplanar. Second is concurrent and non-concurrent system. The forces are passing through a common point are called concurrent, and those which are not passing through common point are called non-concurrent system. So here is Poinsot's central axis. A line through a rigid body which is parallel to the vector sum F of a system of a forces acting on the body and which is located so that the system of a forces is equivalent to the force F applied anywhere along the line plus a couple whose torque is equal to the component of the total torque T exerted by the system in the direction F. In the given figure we can see the axis O dash A dash, that is the axis of a single couple, and the line of action of a single force are resultant of system of force is known as Poinsot's central axis. So what is central axis? If a system of force reduced to a single force and single couple in such a way that the axis of a couple coincides with the line of action of the force, then the line is called the central axis. Here is wrench and pitch. What is wrench and pitch? If a system of force is reduced to a single force R and couple having moment K whose axis coincides with the direction of the force, then R and K is called the wrench of this system. The ratio K by R is called the pitch of the system. And here is the definition of a screw. A straight line along with acting force when considered together with the pitch is known as a screw. So guys, this is all about my presentation. Thank you so much for listening me.